Throughout the United States, state and local departments of transportations, or DOTs, as well as other infrastructure owners and operators, also known as IOOs, are responsible for managing the performance, development, and operation of connected and automated vehicle, or CAV systems. These systems contain complex interactions of various subcomponents, which are crucial for facilitating road safety and mobility applications. The development, testing, and deployment of cooperative driving automation, or CDA, use cases and scenarios brought with it the need to monitor systems and rapidly analyze the generated data. However, there is a lack of non-proprietary tools and technologies that enable engineers and analysts to look at the data quickly and decide if the system is working as intended. To address this need, the CAV Telematics Tool was developed to help understand, track, and analyze the information used in these technologies. The Telematics Tool is an open-source data collection and streaming software that can be installed on any vehicle or infrastructure, such as intersections, traffic lights, and work zones, and can visualize data in near real time with typical latency in the 300 to 400 millisecond range. Containing both hardware and software components, this tool is an open-source web-based tool that enables real-time data collection and streaming from vehicles and infrastructure entities. The CAV Telematics Tool can track multiple different types of data, including current speed, acceleration, distance from end of lane, which is the distance the vehicle can travel within its current lane before it needs to make a decision, such as changing lanes, turning, stopping, and entering or exiting an intersection, vehicle lane status, basic safety messages, or BSMs, and even traffic signal phases. This visualization of various datasets is useful for a multitude of research and deployment endeavors involving connected and automated vehicles, because it allows developers and deployers to immediately view and understand the relationship between various points of data in time. It also provides an easy-to-use dashboard that presents data visually, so users can monitor, plot, and analyze the behavior of entities. This tool is meant to support data collection for any use case involving moving vehicles, such as cooperative driving in work zones, adaptive traffic signal control, and platooning. Recently, the CAV Telematics Tool was utilized in the testing of adaptive traffic signal optimization in a CDA environment. The goal of this use case was for the infrastructure to create less traffic delay by optimizing both signal phases and vehicle trajectories for 3 CAVs approaching an intersection at different speeds. During the testing of this use case, researchers needed to analyze the behaviors of the vehicles in relation to the signal phase plans of the intersection. If their optimization algorithm was working correctly, the vehicles would adjust their speed to arrive at the intersection according to the optimized signal plan communicated by computers connected to the traffic signal controller. By using the Telematics Tool, analysts were able to easily determine the behavior of each vehicle in real time by observing the speed, acceleration, and distance from end of lane over time. Furthermore, the tool allowed them to simultaneously compare the properties of each vehicle with the timing of the optimized signal phase plans. The CAV Telematics Tool allowed analysts to quickly draw connections between each vehicle's data in real time throughout each test run. Without it, they would have had to perform test runs to retrieve and check the data for each vehicle, resulting in significantly longer analysis and testing times. The Telematics Tool consists of 3 bridges as part of software components: a vehicle bridge, infrastructure bridge, and cloud bridge. These bridges create connection between the data source and destination. In its current version, the tool is developed to integrate and function with the open-source Karma suite of tools, developed and provided by US DOT, including Karma Cloud, Karma Platform, and Karma Streets. The hardware components of the Telematics Tool which comprises of a computer acting as edge device and a wireless network provider, should be mounted on the vehicle or on the infrastructure to collect and stream data. The Telematics tool is open source and can be found on GitHub at the following on-screen link. Currently, these data sources are specific to the US DOT CDA program, but the tool can be adjusted to use your own data sources. If your organization is interested in the Telematics tool, you can contact us at CAV Support Services at dot.gov for technical assistance while setting up your Telematics tool instance.